Ladies and gentlemen, today we are going to learn about infrared spectroscopy. Infrared spectroscopy, otherwise known as IR spectroscopy. So we have a bunch of signals that we will see along this x-axis, which is titled wave number. Wave number, same thing as wavelength. So what we need to know is actually not a ton. We have this first region all the way on the right called the fingerprint region. It's called the fingerprint region because every molecule or compound that's going to get sent through an infrared spectroscopy has a region that is indeterminable or undeterminable. Like a fingerprint, everyone is different. Every molecule or compound is different, and it's going to be unreadable. So just know that the fingerprint region is, below 1500, and there's nothing you can do with it. Other than that, we need to know where the double bond region is and where the triple bond region is. We don't need to know any specific signals within those regions just because everything is so similar. The MCAT, the AMC is never going to ask you questions about differentiating bonds within the double bond section or within the triple bond region. So we just need to know that the double bond region is at about 1750 and the triple bond region is at about 2200. 200. Okay, now the single bond region is where it gets a little difficult. Okay, so we need to know three different types. So we need to know the hydroxyl group, we need to know nitrogen and hydrogen, and then we also need to know three different types of carbon-hydrogen bonds. Okay, so let's start with the oxygen-hydrogen. That's the easiest one. It's at about 3300, and it's the only signal that you'll see for the MCAT that would be considered broad. So the blue signal here for the OH is at about 3300, and we can see it's got this kind of broad look to it. It's more spread out. Now the NH is at about 3400. It's about 3400, and that one's spiky as well. Everything else is spiky too. So NH at about 3400. Now there are three different types of carbon-hydrogen signals that'll come off, and it's determined by its hybridization. So if it is sp hybridized, it's going to be A, and if it's sp2 hybridized, it's going to be B. If it's sp3 hybridized, it's going to be C. Okay, so if you're thinking about it left to right, you could say like A is 1, B is 2, and C is 3, if that helps to think about it. That is it for infrared spectroscopy. Actually, that's not true. The other thing that we need to know, they could ask us about just what infrared spectroscopy does, and we need to know this term, vibration. Okay, because they'll ask about what's happening. The molecules, the bonds are vibrating, and they'll also use this other term, stretching. They'll often put them together, or just vibration alone. So like vibration and stretching, or just vibration. So those are two buzzwords, a couple of buzzwords for IR spectroscopy. Subscribe, and leave some comments down below.